As we look at how to estimate limit values from tables, let's go in and review really quickly how we did this from a graph. So let's take a piecewise function. And one of the things you'll learn about limits as we make our way through them is that a lot of times piecewise functions can do things that are really interesting for us. Let's let the function equal 2x minus 3 for all x not equal to 3. And then let's define it specifically as equaling 1 for x equals 3. So let's do a graph of this function. And we know that it is linear in nature, 2x minus 3. So down 3, we can plot our y-intercept. And it's going to have a slope of 2. And I'm going to make sure that I get x equals 3 here in my values. Give myself plenty of values here to go up to and over 1. So if I go up 2 over 1, this next up 2 and over 1 is going to be what puts me at x equals 3. So remember, I'm redefining the function elsewhere. So I'm going to actually use an open hole right there for the fact that x equals 3 is going to be defined as somewhere else. In fact, I can go ahead and define it. X equals 3, I define my function as equaling 1. So I'm actually going to have that point on my function. But then back to this rise over run that I'm doing here, I can go once again up 2 and over 1 and place my points and then draw that linear function 2x minus 3 except at x equals 3 where my function equals 1. And so there's a graph of f of x. Well, as we did in the previous lesson, we wanted to focus first on what the function value at 3 is. I don't want anybody to lose sight of what f of 3 is just because we're doing the limits. F of 3, the function defined, and this is back when you've learned the idea of function notation. If I input 3, my output is 1. The part that's new here in a calculus sense is this idea of limits. And we're going to look at the one-sided limits first, and then we'll talk about the general limit as x approaches 3. So as I'm approaching 3 from the left, or as I'm approaching 3 from below, tracing my function here, the values are getting really close to 3. So I can say this limit equals 3. I can look at the limit as x approaches 3 from above of f of x, and so as I'm tracing from the right, making my way towards x equals 3, the function values again are approaching 3. And because the one-sided limits match, we can say the limit as x approaches 3 of f of x is equal to 3. Now this function was easy enough to graph, and in fact if you can get a graph, that's usually the easiest way to be able to estimate our limits. But the question for this particular topic is going to be, what about functions that aren't as easy to graph? Well, maybe the next best thing, especially if we have a piece of technology that can allow us to evaluate things as we get really close to a value, a table of values can also be a very useful tool to estimate a limit. So this particular function, it was easy enough to graph, but let's say that we had a function that maybe wasn't going to be as easy to graph. It might be easier for us to build a table in order to come up with these same limit statements, and that's what we're going to focus on this lesson.